Okay, so I'm back and we are doing part 2 of the notes, which is 10.6. So this is the back of your note sheet. 10.6 is the opposite of 10.5 is why we do them together. It's going from standard form, right? So that's the numbers we're used to seeing into scientific notation, and that is when we have the times 10 to some power. So let's just go back over what we already learned that's very important to this lesson. When writing very large or very small numbers in scientific notation, right? Scientific notation is some number times 10 to some power up here. That's what it looks like. The factor. We talked about the factor last time. That's the number. This is our factor right here. It's the number that's going to go out in front of the times 10. The factor must be between 1, so it can't be 0.9, it can't be 0.87, it can't be -2, it has to be between 1 and 10, which also means it can't be 10.2 or 10.3, it has to be between the 1 and 10. And then again, it will be times 10 to some power. I put a little line up there. You can put a little n there to show that it's going to be a little exponent. So some of the rules we talked about is when you start with a very large number, so this is a large number, right? It's not a decimal. We know our exponent's going to be positive. So what we need to do is we know we're going to have some number times 10 to some power. I always like to start off with that part because that's a given. We can find the factor, but this part we always know is there, so it's helpful to start. Then we go and we see this number here, 350,000. So I don't see a decimal point in here, but if I made this money, so 0.00, the decimal point would actually be right here at the end. That's what happens with very large numbers. The decimal point is always at the end or farthest to the right. It's always going to be the end. So we know that our exponent's going to be positive, and we just need to count how many we go back to get a factor between 1 and 10. So just looking at this, I know I don't want the decimal point after the 5 because that would be 35. That's not between 1 and 10. I want it between the 3 and the 5, so I have 3.5. So I'm going to put it in there, and then I'm going to write 3.5 here. I know that's the correct factor because it fits this definition. It's between 1 and 10. So then I just count my decimal, my imaginary one. I went ahead and put it in because I need it to count to see how many I go back. So like I said, with a very large number, it's always at the end. We never put it in just because we're not used to writing numbers like that unless it's money. So I'm just going to count. I go back 1, 2, 3, 4, 5. I went back 5. So my exponent is 5. So that's my answer. 3.5 times 10 to the 5th. That's how I write a number that's in standard form, what we're used to seeing in scientific notation. So let's go to another very large number. Remember, a very large number, we don't see the decimal point unless it's money. So I'm going to put it in over here. It's always at the end. That's where the imaginary decimal point is if we were to write it as money. I know that I have to write my number as something, my factor, times 10. And then again, it's going to be to some power. Okay, so let's find my factor first. So I know I need a number between 1 and 10. So if I just go in where my numbers are at, I don't want to put it behind the 5 over here because that's 65. But if I put it in between, I have 6.5. Is 6.5 in between 1 and 10? Yes. So my factor is 6.5. And then from there, all I do is I have to count how many times I went back. So we start at the decimal point that we actually put in there. And we're just going to count how many times we went back to the one we put in. Again, when it starts as a large number, just more than 1, it's a positive exponent. So I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8. I went back 8. And I do that little swooping motion so that I don't lose numbers, because sometimes if you count the zeros, you forget to count the 5. So I always do like a little swoop under each number. You can do it any way you want. I just find it's easier to do it that way. So my final answer is 6.5 times 10 to the 8th, because I moved 8. Okay, look at number 3. So again, this is a large number because it's greater than 1. So if we have 74, pretend it's money, we would have 74.00, but I'm not going to write that in. I'm just putting the imaginary decimal in because we need it to count. Now, I know I'm going to have something times 10 to some power here, right? So all I need to do is count. If I stay here, I'm at 74. I can't have 74 as a factor because it's not between 1 and 10. Remember, that's my rule. The factor has to be between 1 and 10. So this now leaves me, I have to go back and put it here, 7.4. So 7.4. So now I'm going to count. How many did I go back? I went back 1. So 7.4 times 10 to the first power. And that is 74. All right, let's look at the other way. So if you start with very small numbers, that just means numbers that are smaller than 1. They're going to be a decimal. We know that starting with a decimal or a small number, our exponent is just automatically negative. What we do doesn't change. We count going the other way, but it doesn't really matter which way you count. You just remember, if it starts small as a decimal, it's something times 10 to the negative something. I always start writing it that way, or you could even put a box if that helps. You're going to put the number in the box. I know automatically my exponent's negative because I'm starting with a decimal. That's the only thing to remember between the two of these. So you get a positive exponent when you start with a large number, something bigger than 1, and you get a negative exponent if you start with anything that's a decimal smaller than the number 1. So if I were to go, I want to have a factor between 1 and 10. So again, I need the number. If I go here, if I put it right in front of the 4, I get 0.4. Well, that's not quite 1. So I need to make sure it goes after the 4 so that I get 4. You can write a 0.0 if you want after it, but I just like to write 4. Okay? And that's where my decimal would go, is right after the 4. And then I'm just going to count. How many did I go? 1, 2, 3, 4. I actually moved 4. And because it starts, I'm going to put a 4 up here. And because it starts as little, the negative is just a given. It's automatically negative. So this is 4 times 10 to the negative 4. So if you can see this a little better, instead of taking the box away, to the negative 4. That's how I know right here it's a negative 4. Let's look at number 2. Again, we know we have this. Something times 10 to some negative power. So I'm going to put the negative there. I know it's a negative because this number is smaller than 1. When you start with a small number, it's a negative exponent. When you start with a big number, it's positive. So if you look at this, 0.6 is between 1 and 10. It's actually a little bit less than 1. So we do have to do some moves. So I'm not going to move it back here because that would be 0.06. I need it to be between 1 and 10. So it looks like if I put it here instead, I would have just the number 6. So I'm going to do that. I'm going to put the number 6. And then from this one to this one, how many did I move? I put 1 in. I moved it here. 1. So this becomes 6 times 10 to the negative first. And we'll go over practicing checking these in our calculator as well, but it's good to memorize these rules and get used to using them at first. Okay, let's do another one that has a few more numbers that might have a decimal in it. So we have this last one here. We have 0.007345. So again, I need to have some kind of factor between 1 and 10 times 10 to some negative exponent. I'm putting the negative there because this starts as a decimal. It's a very small number. So where would I put the decimal that's going to get me a number between 1 and 10? And I can have a number that's a decimal, like 7 point something or 3 point something. So let's just look here. If I move it over, let's say in front of the 7, 0.7345, nope, that's not between 1 and 10. What about 7.345? This one actually works because 7.345, you can have lots of digits here as long as the number as a whole, our factor, is less than 10 and greater than 1. So I'm going to use this whole thing, and then I'm just going to count how many times did I move. I put my new decimal here, so I'm just going to count. I went 1, 2, 3. So it's a -3 I moved it. So 7.345 times 10 to the -3rd. So that's how we go from standard to scientific. It's just going back and forth. So now what I'm going to have you do is looking at the front and the back. I'm going to have you do your accuracy check to see. We're going to do 1, 2, 3, 4, and 5, 6, and 7. I want you to do that, and then we'll check them. You'll unpause the video. So go ahead and take maybe 5 minutes using your notes and do this part, and then we'll trade with the person next to you or closest to you, and we'll do just a little grading just to see where you're at. Don't forget to use your note pages. So pause now and then take about 5-6 minutes to check this over. Okay, so hopefully you came up with similar answers to this. For number 1, it's no, because the 12 is bigger than 10, so that's not a correct factor. Number 2, that was all from 10.5, the first part. So what we did was, because it's a positive exponent, we want a bigger number, which means we go right. So you have 60 million, right? Next, for number 3, again, it's a negative exponent, so we need a very small number, so that means we're going to go to the left, so you get 0.000099. Number 4, it's a positive exponent, so again, we need a bigger number, so we're going to go to the right, so it's 12,850. And then 5, 6, 7, and 8 are very straightforward, what we just did on part 2 of the notes. Just go ahead, pause this, and check your answers. And then we'll talk about 7 real quick. Okay, 7 was the only tricky one. This was already a factor. So when we look at number 7, it's actually between 1 and 10. So we rewrite it, 3.6 times 10. And here's where we learned our old rules. 10 to the 0 power is always 1. So 3.6 times 1 is 3.6. But what that really means is 3.6 times 10 to the, you moved 0 spots because it was already a factor between 1 and 10. So that was the only real tricky one. I think the other ones were straightforward, like the notes. So what you're going to do now is you have all your notes and practice filled in. You are going to do the mixed review. The front is 10.5, and then the back, you're going to do, the bottom part is actually 10.6. So going from standard form to scientific and scientific to standard form. If you do not finish, this is homework. If you need to rewatch either part 1 or 2 of the video for homework, feel free. They are on Google Classroom. And I will see you soon, and we will check these in the next time I see you.